In this video, we will talk about how to normalize a vector. So let's check out a couple examples. Let's say we have some vector u with the values 1 and 2. How can we normalize this vector? Well, to normalize a vector, we simply divide each of the values by the length of the vector. So here's how we write that. We say u hat, which is the normalized vector, we use this little hat to indicate normalized, is equal to the values in the original vector divided by the length of the original vector. And we use these double bars to indicate the length of a vector. So how do we calculate the length of a vector? Well, let's write that over here. We say the length of u, vector u, is equal to the square root of each of the individual elements squared and added together. So we say 1 squared plus the next value is 2, so 2 squared. So the length of vector u is 1 squared, 1 times 1, that's just 1, plus 2 squared, 2 times 2 is 4, so 1 plus 4, so 1 plus 4 is 5. So the length of vector u, we say, is the square root of 5. So to write the normalized vector u, we simply divide each of the individual values by this length, the square root of 5. So we would say normalized vector u is going to be equal to 1 divided by the square root of 5, and 2 divided by the square root of 5. This is the normalized vector. And what we'll find is this normalized vector, or sometimes it's called a unit vector, it has a length of 1. And we can verify that by calculating the length of this vector. So, for example, if we were to go over here, let's make a little room. So we said this was our normalized vector. To calculate the length of this normalized vector, remember we can do the square root of the first value squared, so 1 over root 5 squared, plus the second value squared, so 2 over root 5 squared. So what do we get when we do that? Well, when we square a fraction like this, we can square the numerator and square the denominator. So we get 1 squared is just 1. The square root of 5 squared, or in other words, square root of 5 times the square root of 5, is just 5. And then we have plus 2 squared is 4, so we'll say 4 over, once again, the square root of 5 squared is just 5. So we get 1/5 plus 4/5. Since these fractions have the same denominator, we can just add the numerators to get 1 plus 4 is 5, so 5 over 5. Well, 5 over 5 is just equal to 1, so this whole expression is equal to the square root of 1, and the square root of 1 is just 1. So we have verified that this normalized vector does have a length of 1. And one thing to note is that this normalized vector, or sometimes we call it a unit vector, it has the same direction as the original vector, but it simply has a length of 1. So keep that in mind. All right, let's try one more example. Let's say we have vector v with the values -2, 3, and 2. How can we normalize this vector? Well, remember the first step. We need to first calculate what is the length of the vector. So what is the length of v? So we say that's the square root of -2 squared plus the next value, 3 squared, plus the last value of 2 squared. So we get -2 squared is 4, plus 3 squared is 9. So let's write this out. 4 plus 9 plus 2 squared is also 4. So we get 4 plus 9 is 13, plus 4 is 17. So the length of this vector, we say, is the square root of 17. And remember, to write the normalized vector, we simply divide each of the values by the length. So we would say the normalized vector, v hat, is going to be equal to -2 divided by root 17, and then 3 divided by root 17, and lastly 2 divided by root 17. This is our normalized vector. And once again, if we wanted to, we could verify that this vector does indeed have a length of 1 by calculating the length. So let's do that right here. So let's say the length of this normalized vector is going to be the square root of all of these values squared and added together. So we have -2 over root 17 squared plus 3 over root 17 squared plus 2 over root 17 squared. So we get negative 2 squared, that's 4, over square root of 17 squared is just 17. Plus 3 squared is 9, over the square root of 17 squared, once again that's 17, plus 2 squared is 4, over the square root of 17 squared is just 17. So because all of these fractions have the same denominator, we can simply add the numerators. So 4 plus 9 is 13, plus 4 is 17. So we get 17 over 17, which is just equal to the square root of 1, which we said earlier, the square root of 1 is just 1. So that's how we can verify that this normalized vector does indeed have a length of 1.